IITians.
Hello friends, in this video we will discuss about some important concepts of quantum mechanics. We will first discuss some important problems, and by discussing those problems I will tell you how to solve problems for CSIR-NET or GATE exam. When you like there is a quantum mechanics problem, don't feel so much nervous. It is easier if you see this whole video, if you watch and understand step-by-step processes. So let's start the video. So the first question is a very basic question, may not be asked in NET exam, but it can be asked in GRADE exam or IIT JAM exam. So the question is that transform the coordinate system provided below. So this is the coordinate system. So the following functions you have to transfer it or transform it accordingly. The first is the from Cartesian to spherical polar coordinate. The function is 3x plus y minus 4z equals to 12. And the second question is from Cartesian to cylindrical coordinates, y square plus z square equals to 9. And the third question is from spherical polar coordinate to Cartesian coordinate. And the function is r equals to 2 sine theta cos phi. So this is a very basic question. The let's solve let's see how to solve it. So the first function is 3x plus y minus 4z, which is a Cartesian function. It is involved with x, y, z. And now you have to transform this Cartesian function to the spherical polar coordinates. So first of all, you have to know that what is spherical polar coordinates. So spherical polar coordinates involves not with x, y, z. It involves with r, theta, phi. Now, to transform from a one coordinate system to another coordinate system, you have to know the correlation between them. That how do you transfer x to the coordinate system of that polar new coordinate system, that is polar coordinate? How do you transform y to that polar coordinate? And how do you transform z to that polar coordinate? So for the polar coordinate, x equals to r sine theta cos phi, y equals to r sine theta sine phi, and z equals to r cos theta. So the first function is 3x plus y minus 4z equals to 12. So 3 into, in terms of in place of x, there will be r sine theta cos phi, plus y, it will be r sine theta sine phi, minus 4. For z, it will be r cos theta. That should be equal to 12. So you simplify it and you will get the solution as if you common r will be common for all this three. So r will be outside, so it can be written as r of 3 sine theta cos phi plus sine theta sine phi minus 4 cos theta equals to 12. Okay, so this is a very simple thing you have to do. You need to remember this. Not to remember, I should tell you, you should understand how there is a coordination transformation is occurring here, and also need to remember this formula. If you understand, then you can also derive by yourself also. The second function is, so y square plus z square equals to 9. So from Cartesian, you have to transform to a cylindrical coordinate for this function. So first of all, you have to know what are the transformation equations for Cartesian coordinate to transform it into a cylindrical coordinate, right? So for Cartesian to cylindrical coordinate, the relation are x equals to r cos phi, y equals to r sine phi, z equals to z, where r square equals to x square plus y square and tan phi equals to y by x. These are the relations. So the given equation is y square plus z square equals to 9. In place of y, you write r sine theta, r sine phi. So it will be y square will be r square sine square phi plus z square equals to 9. Hence, this is the transformed equation. And the question number 3 or C is from spherical polar to Cartesian coordinate. The first one was the from Cartesian to spherical. The third one is from spherical polar to Cartesian. And the equation is r equals to 2 sine theta cos phi. So r equals to 2 sine theta cos phi. So here in place of sine theta cos phi, we know sine theta cos phi equals to x by r. So we put it r equals to 2 into x by r. So if you write it down simplifying it, it will become r square equals to twice x. Now r square we know r square equals to x square plus y square plus z square. So x square plus y square plus z square equals to 2x. X square minus 2x plus y square plus z square equals to 0. So further simplifying, you will get the final equation x minus 1 whole square plus y square plus z square equals to 1. So this is all. So come to the next question. So here from this question, what you understand that to transform a equation from particular coordinate system to another coordinate system, you have to know the transformation equations and just put it in the simplest form. Okay. The next question, it is a question from the book Jetley, I know. Jetley from quantum mechanics. So I think this question is very relevant and it is an exercise problem. So you must know how to solve this kind of questions. This is very important, very much important for NET, GATE and JEST examinations and also for the JAM examination. So the question is, a particle of mass m which moves freely inside an infinite potential well of length a has the following initial wave function at t equals to 0. So the wave function at t equals to 0 is psi x comma 0. The position is x and time is 0 equals to a divided by root a sine pi x by a plus root 3 by 5a sine 3 pi x by a plus 1 by root 5a sine 5 pi x by a, where a is a constant. Now you have to find a so that this psi at x comma 0 is normalized. So you have to find out the normalization constant. So first of all, so let's focus how to find the normalization constant or a. So this is the function that is phi n x equals to root over 2 by a sine n pi x by a. And we know that we we can do it by orthonormalization condition. So first of all, I also tell you the meaning of normalization, that why we need to normalize a function. This is because we treat their magnitude square as a probability. So this probability should be finite and at any region it should be always 1. If you consider the probability, if it is a realistic particle, physical particle, the probability of the particle to find at an instant of time at any particular position should be 1, not like 1/2, not like 1/4. This is very important. Not like half of the particle can be found here and half of the particle can be found on the other side of the planet. It cannot be possible. It should be always 1 to be a physically realistic particle. That is why we do normalization. Okay, so whenever you study physics, always try to understand the physics behind it, behind any problem. So you have to put the orthonormalization condition, that is you take two wave functions psi n and psi m and you take the bracket operator like the n get psi n. So it should be written like 0 a for that particular position phi n star phi m dx. So it will become root 2 by a sine n pi x by a and another will be root 2 by a sine m pi x by a, right? So root 2 by a will be 2 by a. It will be a constant, so it will be outside the integration and this integration limit from 0 to a. So sine n pi x by a sine m pi x by a dx should be delta mn. So delta mn means it is a Kronecker delta function. When m equals to n, that will be 1, otherwise it will be 0. So now you can write more convenient to write in this term that psi x comma 0 in terms of phi n x. So psi x comma 0 is a by root a sine pi x by a plus root 3 by 5a sine 3 pi x by a plus 1 by root 5a sine 5 pi x by a. And so it can be like psi 1, it can be sorry, it is phi, so phi 1, phi 3, phi 5. So phi 1 will be a by root 2 to phi 1x plus root 3 by 10 phi 3x plus 1 by root 10 phi 5x. So now since this is 1, when n equals to m, so we can take this normalization condition and write this like a by root 2 phi 1 x. So you have to consider that all this phi 1. So phi 1 into phi 1, so phi 3 dot phi 3, phi 5 dot phi 5. So all will be like, so you will, rest of it, you will get that a square by 2 plus 3 by 10 plus 1 by 10. So this is a mod square. So this value should be 1. So from here you get that a equals to root 6 by 5. So finally you get the equation psi at x comma 0 equals to root 3 by 5 phi 1x plus root 3 by 10 phi 3x plus 1 by root 10 phi 5x. So whenever you need to find out the normalization condition, you have to put the or orthonormalization condition you have to apply. The next question is, if measurements of the energy are carried out, what are the values that will be found and what are the corresponding probabilities? Calculate the average energy. So you have to calculate the probability of the energy, like which state will have how much of probability to have that energy, and also you have to calculate the average energy. So uh, how do you find out the energy eigenvalue? So you can find out energy eigenvalue by using this equation, that is En equals to bra phi n h cap phi n. So this is that H is the Hamiltonian, which can be written as minus H cross square by twice m d2 phi by dx2 or d2 dx2 over that wave function, right? So phi n star d2 phi n dx2 dx integration over 0 to a, and which is the energy eigenvalue, and it is n square pi square h cross square by twice m s square. So now, if suppose this measurement is carried out on the system, now this energy eigenfunction will have this En with a corresponding probability Pn En equals to mod of phi n psi whole square. That is the probability. So the initial wave function contains only three eigenstates because initial wave function components are phi 1, phi 3, phi 5. So the thus this phi 1, phi 3, phi 5, these three wave functions have the probability of energies that we can find it out by E1 equals to phi 1 h cap phi 1, E3 equals to phi 3 h cap phi 3, E5 equals to phi 5 h cap phi 5. So these are the eigenvalues, and the probability will be the mod square of that. So E1 is mod of phi 1 psi whole square, P3 for E3 is mod psi 3 phi whole square, and P5 E5 is phi 5 psi whole square. So this phi 1 is pi square h cross square by twice mn square. The for the first energy excited state, or for the and this is the n equals to 1, and for n equals to 3 is 9 pi square h cross square by twice m square, and for n equals to 5 it is 25 pi square h cross square by twice m s square. So the corresponding probabilities are, so you can find here from this wave function, this is root 3 by 5 phi 1x, root 3 by 10 phi 3x plus 1 by root 10 phi 5x. This is wave function. So you take the mod square. So mod square, this is for phi 1, that only 3 by 5 will survive, other terms will not be there present. So the dot products will be 0 for phi 3 phi 5. So this root 3 by 5 into root 3 by 5 will be 3 by 5, or P1 or probability of energy for E1 state. For P3 is root 3 by 10 into root 3 by 10, that is 3 by 10. And for P5, root 1 means 1 by root 10 into 1 by root 10, that will be 1. So these are the probabilities. So what I have done here, I have first find out the energy eigenvalues. Like we have to find out first the energy eigenvalues by using this wave function, given wave function, and then you find out the three energy eigenvalues, that is E1, E3, E5 for corresponding n values, and then you have to find out the probability of energy using the wave function mod square. So for that particular state, you have to consider that only that particular state, the whole state, on the whole wave function. So it is like taking a mod square value of that particular state over the entire wave, and that will give you the eigenvalue energy or probability of energy for of having for the, being occupied by that energy state. So this is very important to understand that why we are doing this particular operation, find out the probability of particular energy occupied by that level, and it is pretty understandable. And the next question is that determine the probability of find the wave function psi x comma t at any later time. So initial time is given, and also yeah, another question was the average energy. So you have to find out average energy by using this formula, that is average of all the probability into the energy eigenvalue. So probability is 3 by 5 into E1 for first one, plus 3 by 10 into E3 plus 1 by 10 into E5. So it will become 29 pi square h cross square by 10 m s square. Now the second question is that what will be the wave function after any later time t. So the initial wave function psi x comma 0 is given, and after the any later time t, the wave function is psi x comma t. So psi x comma t can be written as the initial wave function, that is root 3 by 5. Yeah, so we have find out that initial wave function, that is root 3 by 5 phi 1x plus root 3 by 10 phi 3x plus 1 by root 10 phi 5x. So now what you have to do, you have to take this time evaluation factor, that is e to the power minus iota e1 t by h cross, which is also telling you the how it is evolving with respect to time, how the wave function is evolving with respect to time. So since this is a wave, so in general, any kind of wave can be expressed as a general, that is exponential function. It can be either expressed cos, either expressed sine. It can be a equation, complicated equation. It can be tell all the combinations of sine, cosine. So this is the time evaluation factor which you have to include when you need to consider the wave function at a later time. The time is t, and you have to consider the energy values for that particular state as well. So for phi 1, the energy eigenvalue is E1, for phi 3, E3, for phi 5, E5. So these are these expressions En and phi n are already given. So, and the last question, that question number D, that determine the probability of finding the system at a time t in the state phi x comma t is root over 2 by a sine 5 pi x by a exponential minus iota e5 t by h cross. Then determine the probability of finding it in the state phi x comma t equals to root 2 by a sine 2 pi x by a exponential minus I e to t by h cross. So you have to first determine the probability of the finding the system at any time t in this state phi, and then determine the probability of finding it in the state chi. So these are the two different states. So how do you do this? So probability of finding this is first use express this phi xt in terms of phi n. So phi xt can be like root 2 by a sine 5 pi x by a e to the power minus I e5 t by h cross, or it can be written as phi 5 e to the power minus iota e5 t by h cross. The probability of finding the system at a time t at the state phi, which is a function of xt, it can be written or expressed as p equals to mod square of bra psi bra phi ket psi. So it will give you, after simplification, you have to consider the wave function within that limit, within that space limit 0 to a. So it will become 1 by 10. So since this phi 1 is this dot product phi 3 is 0, and phi 5 is only exponential I e5 t by h cross. And similarly for chi, that another wave function, you can write it like simplify it like phi 2x exponential minus I e to t by h cross, and we have to consider the probability like the previous way, that is p equals to mod square of chi over psi. So what is your operation? Which state is important? You always do it in the bar notation, and it will be it will be, the ket will be like the whole wave function. So this is giving the equation. You solve it and you get the integration value to be 0. So these are all for this previous question. Hopefully you understand it And you understand practical also that how to solve this question, this type of questions. If there are some like a twist, you should able to do that, how to solve this question. Okay? And the question, another question, it is an exclusive problem that is not given in any book. The problem is that for each of the one-dimensional potential energy graphs shown below, determine whether you expect symmetry to lead to a separation into odd and even functions. The second question is whether you expect the energy to be quantized, continuous, or both. And the C is the boundary conditions that apply at each boundary, that is psi and del psi del x is continuous, is all that is necessary. So first of all, three different gauge of wave functions has been given, and you have to determine these are all one dimensional potential. So you have to tell them whether you expect a symmetry that can lead these equations, lead the solutions to be two different solutions. One is for even, another is for odd wave function. The second question is whether the energy will be quantized, or the energy will be continuous, or will be both responsible for this wave function. And the three, the boundary conditions about psi and delta psi for del psi del x for three kind of. Hope you understand. This kind of questions is important if you face something different, and this is very conceptual question. So first of all, I think you all know about the bound state, but I tell you that in quantum mechanics, a bound state is a quantum state of the particle that is subject to a potential such that the particle has a tendency to remain localized in one or more region of space. The particle is to remain localized, it is a bound state. Okay, so first this, see this kind of potential, this is potential barrier, so having a length of 0 to from 0 to L. So there due to the symmetry it will break the solutions. So there will be like symmetry will break the solution for the even functions, and for the odd wave functions you will get to different solutions. And also there are continuous states, and the boundary condition you have, that is psi and psi prime, that is del psi del x, should be continuous at this boundary x equals to 0 and x equals to L. So boundary condition, that is del psi del x, should be continuous and psi should be continuous. It is very much important to get a well behaved function. The second one is the potential well, having a length of 0 to L, and this is V naught. So here this symmetry will break the solutions to even and odd solutions, and here both the bound states and continuous continuum states exist, and these two boundary x equals to 0 and x equals to L, psi and psi prime are continuous, and we have taken here the energy, particle energy is less than V naught. Okay, for this too. So this is very important, that what is the energy of that particle or of that wave, and also yeah, of that particle. And the third one is this kind of potential, like minus from minus V naught, it is going towards 0. So there are both bound conditions and continuous conditions for the particle having energy E from minus V0 to 0. So it is particle has energy in between. There is no symmetry for all, but here the boundary condition will be at this point psi should be continuous, and psi prime or del psi del x should be also continuous. So this should be these are the conditions, and if you face this kind of problems, you need to solve, you need to understand that what are the potentials and how the shape of the potential, what is the energy of the particle, whether it is less than the potential or not, whether it is greater than the potential, and what are the conditions or of the what are the boundary condition it should be satisfied, it should satisfy to become a well behaved function. And this is like some of the example of a continuum state and a bound state. So if it is like this particles energy within this range, so there will be bound state. Particle energy within this range, that is more than this well, then it will be continuum state. So there is suppose a waveguide. So this is like for energy. If you plot this k versus omega solution, that is dispersion relation, you see this state will be continuum state and this will be the guided modes. So suppose you make it modulated waveguide, then you are actually making a different kind of potential. So it will give you the different kind of energy levels and different, these are the guided modes, these are the continuum modes. So guided means that like discrete modes, okay, which will be completely guided by that wave guiding, like light will be guided by this wave, light or any wave can be guided. So these things are important and very practical to know the quantum wave functions and the energy values to understand the behavior of that particle in the quantum regime. That's why it is very important. And this one is the last problem which I would like to give you as your homework. So suppose there is a this is taken from Griffith Quantum Mechanics book. So the Gaussian distribution is rho of x equals to a e to the power minus lambda x minus a whole square, where a, small a, and lambda are constant. Now use this equation to determine a, find average of x square average, and sigma, and that is uncertainty of standard deviation, and also sketch the graph of rho of x. So hopefully you will do this and tell me the answer. So friends, thank you so much for watching this video. We have test series program, we have interview guidance program, and also PGP guidance program, which will be very much helpful for you to prepare your CSIR-NET, GATE and JEST examinations. And this test series program is very much like well organized with different questions, and we will take weekly interview of your test series program, like how the test series goes on, and further we will guide you how to perform it really more fruitfully, efficiently. That is all our effort to make you like qualify this exam and make you able for this PhD admission. So to know details more about us, you can contact to this number. You can also like our Facebook group and page Physics by IITians. You can also like our Telegram group Physics by IITians. You can discuss there. You can solve your doubts there. And these are our PGP courses. That is languages we offer: Python, Linux commands, shell script, LaTeX, and it is useful for your research also. And also, if you get some doubt, you can directly contact us. We can live interact with you with your homework problems. And these are all within minimum cost. So that is very important. So be motivated. Thank you for watching this channel, and you can qualify your exam. All the best. Please do subscribe our channel, like this video, share with your friends. Thank you.